Alright, welcome back everyone. So we are going to start learning about database normalization and denormalization. Normalization and denormalization is one of the basic optimization concepts of relational data modeling. Relational models are used in relational databases which they store the data in the form of tables, and these tables contain rows and columns. And if we think about what are the generally used relational databases in the market, they are SQL Server, Oracle, MySQL, and etc. So let's start with normalization. Database normalization is the process which helps the database designer to divide large tables into smaller ones to minimize the data redundancy. But what is data redundancy? So data redundancy is a data organization issue that allows the unnecessary duplication of data within your database. A change or modification to redundant data requires that you make these changes to multiple fields in your database. So look at this sample. Suppose that we have a student table that includes student information as well as the course they have registered. We have 4 students in here, and you see that each of them have registered to same course. Therefore, the course ID and the course name information is repeated for each student. And this is named as redundancy. But the result of the redundancy, we encounter the anomalies during the insertion, deletion, and update processes in database. Okay, the first one is the insertion anomaly. When a new student is added to student table, then entire information will be inserted. That means the course details will be repeated in the student table. For such a small table, it doesn't make a big difference, but when you consider thousands, even millions of student data, replication could consume quite amount of disk space in your database. Additionally, insertion anomaly happen when inserting vital data into the database is not possible because the other data is not already there. For example, assume that the course ID and course name is defined as they are not allowed to be null, and if a new student is enrolled but not immediately assigned to a course, then this student could not be entered into the database until they have registered for a course. And this results in inconsistencies in the database. Deletion anomalies. It happens when the deletion of targeted information causes desired information to be deleted as well. For example, if the details of student in this table is deleted, then the details of college will also get deleted. When we delete all student information, then we will also lose the college information as well. So it is not possible to delete some information without losing some other information in the table as well. And the last one is update anomalies. In the above table, suppose that the course name is changed from coding to Java. If we want to update the course name, we need to update each record in the system. And somehow, if we miss any of the record, there will be inconsistent data in the database. So we will see both coding and Java in the system as referring the same object. These are all issues which may occur due to data redundancy. But how we will solve redundancy and anomaly problems? To overcome these anomalies, we need to normalize the data by using normal forms. Normalization rules are divided into the following normal forms, but we are going to focus the most commonly used ones. According to the rule of first normal form, an attribute of a table cannot hold multiple values. It should include only atomic values. Suppose that the same student enrolled more than one courses, like Jim Black and Martin Killen registered both coding and accounting courses. As you see in here, in source table, different course information is stored in the same cell. So this table violates the first normal form, as the rule says each attribute of a table must have atomic values. To make the table complies with the first normal form, we should have the data like this, as each course information is separated into different cells in the course name column. So you may notice in here we still data redundancy problem in this table, as almost all columns are replicated as student, state, country information, but we're going to solve them with the following normalization forms. Okay, the next one is the second normal form. So to be in second normal form, a table must be in the first normal form and relation must not contain any partial dependency. So let's understand this with a simple example. When we look at the source table, we expect that student ID is the primary key field which uniquely identifies each record in the table. But something is different in here and we are not able to define each single record by just using student ID column. The column is repeated due to that the student is registered more than one courses, and that cause we have to use both student ID and course name information in order to make each record unique, and that indicates the composite key. If you remember, when relationships with a primary key compose of two or more attributes, it is referred as a composite key. Second normal form table should avoid the composite keys and should not have redundant data due to it. To solve this, redundant data is separated into different tables and created relationship between them using the foreign key. So you may notice in here, we have created a new course table and as well as a bridge table that provides relationship between the student and course. The reason behind this, there is a many-to-many relationship between student and course information. A student may enroll for more than one course and a course can be registered by multiple students. As we are familiar from earlier session, we use the bridge table to solve many-to-many relationships, or in other words, we could simply imply composite keys indicates the many-to-many relationships. We extracted the composite key columns from student table and embedded into bridge table, and also separated out the course information into course table. By this way, our tables now are in the second normal form. But still we didn't finish the job, as we see in here redundant country information which we are going to solve with the next normalization method. A table is accepted in the third normal form when it is already in the second normal form and it doesn't have any transitive dependency. So we already turned our student table into second normal form, so the first prerequisite is already checked. So let's look at the transitive dependency. If a non-key column depends on another non-key column, that is called a transitive dependency. In other words, columns which are not directly dependent on the primary key is separated out to another table. And what does it mean? You may notice in here state column does not directly depend on the student ID. If the country changes, then state also changes. It means state column depends on country column as well. So these columns can be separated into another table. We have created a new table as origin including state and country columns and constitute a primary key as well. By this way, we get rid of the redundancy in student table and finally our model has transformed into the third normal form. So we have seen how database normalization can decrease redundancy, increase efficiency, and reduce anomalies by implementing three levels of normal forms. And the next database optimization technique is denormalization, where data from multiple tables are combined into a single table so that data retrieval will be faster. This can help us avoid costly joins in a relational database and increase the performance of a database infrastructure. But please keep in mind, denormalization does not mean avoiding normalization. It is an optimization technique that is applied after doing normalization. So when we look at the following table, all normalized tables are gathered into a single table. So let's move on and do a detailed comparison between normalization and denormalization. So normalization divides large tables into smaller ones in a relational database with the help of series of normal forms in order to reduce data redundancy, improve data integrity, and to remove, insert, update, and delete anomalies. During normalization, as data is reduced, number of tables and hence the joins are increased. Even though normalization creates multiple tables, insert, update, and delete are the most efficient in this regard. Because if we have to insert, update, delete any data, we have to perform the transaction only in that particular table. Therefore, there is no fear of data loss, and that helps the speed of update, delete, and write operations is higher. It is used in OLTP systems which emphasize the fast write operation. In normalization, Memory space is optimized because memory consumption is lower due to less redundancy. When we move on to denormalization, denormalization is the process where data from multiple tables are combined into one table, and that creates data redundancy as duplicate data may be found in the same table, and result of it, number of tables and hence the joins are decreased. Because the tables hence the joins are decreased, data retrieval will be faster, and that leads us to achieve faster execution of queries. Denormalization is used in OLAP system which emphasize fast read operations by making the search and analysis in an efficient way. In denormalization, data integrity needs to be taken into account carefully because all duplicate data is in a single table. When inserting, updating, or deleting tables, you may encounter anomaly issues. Memory space is not optimized in denormalization because duplicate data is stored in a single place. So let's think about why normalization is important for OLTP systems. In OLTP systems, as we mentioned, the main emphasis is the fast insert, update, and delete operations. So normalized data models decrease the data redundancy, and that causes one data is in one location. Therefore, in order to do any change regarding any specific record, you need to access to single location. So let's look at a sample. In here, we see a sales database of a company that includes detailed information about order of the products which is done by a customer from different stores. So database is normalized and data is separated out into 7 different tables. So let's observe how the right operations behave in here. Suppose that in this company we made an organizational change in product categorization. In earlier times, we used to sell only computers and relevant accessories in terms of electronic devices and collected all this product under the category of computer. But later on, we extended the product range and started to sell other electronic devices like television, soundbar, phone, or etc. and gathered all these products under the same category by converting computer category to electronic. In database, category name is stored in the product category table. So if you would like to update the category name, as you see in here, it is sufficient to update single record of data. So it seems quite effective when we try to update hundreds or thousands of data. But if I would like to execute a query in the system, so let's think about how it's gonna work. I want to query the database with the question of, please give me the customer name, surname, and email address which has bought products from electronic category in the store of Los Angeles. In order to access this information, I need to touch almost all tables. I need customer table for details of customer and order header child tables in order to find the transaction detail, and also need product category and store information. So I need to join 6 different tables in order to get an answer to my question. Does not seem promising, but we still need a benchmark in order to compare. So look at how the things works on the OLAP side. Denormalization is the emphasized optimization technique in OLAP systems where data from multiple tables are combined into one table, and that creates data redundancy, but on the other hand, it decreases number of tables, hence the joins. So in here, we may already witness that product and category tables are combined and turned into a single table, and that causes data redundancy. As you see in here, the columns, color, or product name is repeated. For the right operations, I still have the same scenario and would like to update the category name. But in here, due to redundancy, I need to update 3 different cells instead of the one which we already discussed in previous OLTP model. So it seems my workload is increased and became complicated, and on the other hand, if I miss to update any record, it would cause data inconsistency in the system. And in terms of query execution, if I ask the same question in denormalized model, give me the customer details which has bought products from electronic category in the store of Los Angeles, then it is sufficient for me to join only 4 tables. So we realize that normalizations bring better results in OLTP systems which have the main focus of the fast write operations. And on the other hand, due to increased number of table and joins, it does not perform well in terms of query execution. And against this, Denormalization is used in OLAP systems which emphasize fast read operations. Because the number of tables and joins decreased, data retrieval became easier and faster. But however, due to data redundancy, write operation may cause anomalies in the system. So I hope that gives you a better understanding about what does it mean normalization and denormalization. So thank you for listening.